Welcome to the deep dive, everybody. You ready to dive deep?
Always ready.
Awesome. Today, we're going deep on machine learning, security, and privacy.
Sounds intense.
Oh, it is. Trust me. It's super relevant, though, even if you aren't, a tech whiz or anything.
Yeah, I think people would be surprised how much this stuff affects their everyday lives.
For sure. Okay, so we're going to be focusing on this paper. It's called, get this, SoL, Security and Privacy in Machine Learning.
Catchy title.
I know, right? Published back in 2018 by Nicolas, Papernot, and a few other researchers. And let me tell you, these guys are brilliant.
They really are. This paper was a landmark study.
It was. It basically laid out a framework for understanding all these security risks that come with AI. And I think, for our listeners, it's like a cheat sheet to help them understand this increasingly important but also kind of scary world of AI.
Yeah, I mean, as machine learning becomes more and more integrated into our lives, we really need to understand the ways it can be attacked.
Absolutely. And how to protect ourselves. Like, did you know that just making tiny changes to data can make AI systems go totally haywire?
Oh, yeah, and then you have models being tricked into revealing private information. It's wild.
It's nuts. We're going to unpack all of that and more today, so buckle up.
Should be a fun ride.
Okay, before we get too deep into the weeds, let's do a super quick machine learning 101. Just a refresher.
Okay, sounds good.
So for anyone who hasn't been, living and breathing algorithms, can you give us the simplest possible explanation of what machine learning is?
Sure. At its core, machine learning is all about teaching computers to learn from data.
So instead of programming them with specific rules, we're basically saying, hey, figure it out yourself.
Exactly. It's more like guiding them toward learning, like you might train a dog.
Ah, so it's like teaching a dog in a trick. You give it treats when it does the right thing, and eventually it learns the behavior you want.
Exactly. Except in machine learning, we use data instead of treats.
Data treats. Got it. So the AI munches on data and learns to do cool stuff like, I don't know, identify spam emails.
Exactly. Or predict what movie you'll want to watch next on Netflix.
Or even drive a car. It's kind of freaky how much they can do.
It is pretty amazing. And there are actually a few different ways to train these AI systems. Sometimes we give them labeled data, which means we tell them exactly what each piece of data represents.
Like, hey, this is a picture of a cat. This is a picture of a dog.
Right. That's called supervised learning. But sometimes we just give the AI a giant pile of data and let it figure out the patterns on its own.
So it's like, here's a million pictures, good luck.
Exactly. That's unsupervised learning.
Makes sense. So whether it's being spoon-fed information or figuring things out on its own, the AI is basically learning from data to make decisions or predictions.
Precisely. And it's important to remember that there are two main phases in this process, training and inference. During training, the AI is, well, learning from the data. Then during inference, it uses what it's learned to make predictions on new data it hasn't seen before.
So training is like school for the AI, and inference is where it goes out into the real world and puts its knowledge to the test.
That's a great way to put it.
Now, this is where things get interesting and maybe a little unnerving. The paper we're looking at today talks about how AI systems, for all their smarts, can be surprisingly vulnerable.
More vulnerable than people realize, I think.
Yeah. They can be attacked, and those attacks can happen at different points in the process, right? Like during training or during inference.
Exactly. It's helpful to visualize it like someone walking into a bank.
Yeah.
There are multiple points where a robber could try to interfere. They could try to break in during the night, or they could try to hold up the tellers during the day.
Oh, okay. So it's kind of like that with AI. There are multiple points where things can go wrong.
Right. And this paper uses a framework called the CIA triad plus privacy to categorize these vulnerabilities.
CIA, like the spy agency.
Not quite. In this context, CI stands for confidentiality, integrity, and availability. These are the three core principles of information security.
Okay, I'm intrigued. So how do these principles apply to the world of machine learning? Break it down for me.
Let's start with confidentiality. Think about a company that's poured millions of dollars into developing a super sophisticated financial model using machine learning. That model itself is incredibly valuable. It's like their secret sauce.
Yeah, so if someone could steal it, that would be bad news.
Disastrous.
Yeah.
So in this case, confidentiality means protecting that AI model itself or the sensitive data it's trained on.
Kind of like protecting the recipe for Coca-Cola.
Exactly. Now, integrity is all about making sure that the AI's predictions haven't been tampered with. Imagine a facial recognition system that's used for security.
Like at an airport or something.
Right. If an attacker can manipulate the system, they could make it misidentify someone, which could have serious consequences.
You're talking about someone getting access they shouldn't have, or even worse, someone being wrongly accused of something they didn't do.
Exactly. And then we have availability, which is making sure the AI system is actually up and running when we need it. Imagine a self-driving car. If an attacker can disable the car's AI, it could cause a major disruption, even an accident.
Okay, that makes sense. So that's confidentiality, integrity, and availability. What about the plus privacy part?
That's all about protecting the privacy of the individuals whose data was used to train the AI.
Right, because we're using AI on increasingly personal data these days, like medical records, financial transactions, all that stuff.
Exactly. So privacy, in this context, is about preventing the AI from leaking sensitive information about those individuals.
So if an AI is trained on medical records, we wouldn't want it to accidentally reveal someone's private health information when it makes a prediction.
Right. We want the AI to be able to learn from the data without giving away the individual data points that made up that learning.
Okay, I'm starting to see how this all fits together. So we've got our CIA triad plus privacy, and we know that attacks can happen during either training or inference.
It's like a multi-layered security problem.
It is. What are some of the ways those attacks actually play out in the real world? What are the techniques that these digital robbers are using?
Well, to understand that, it's helpful to imagine a real-world scenario where someone is interacting with an AI system. Let's take an autonomous vehicle as an example.
Okay, I'm picturing a self-driving car cruising down the street.
Right. Now, an attacker could try to interfere with the car's AI at several different points. They could tamper with the sensor data the car relies on, basically feeding it false information about its surroundings.
So tricking the AI into thinking there's an obstacle in the road when there really isn't.
Exactly. Or they could attack during the model training phase.
Back when the car's AI was still learning how to drive.
Yeah, exactly. They could subtly poison the data used to train the AI, causing it to learn dangerous behaviors.
Yikes. So instead of learning to stop at a red light, it might learn to speed up. That's terrifying.
It is. And what's even scarier is that these attacks can happen during the model's use while the car is on the road.
Wait, so even after the car has graduated from AI driving school and is out there in the real world, it's still vulnerable. How is that even possible?
It is. And that's what makes these attacks so difficult to protect against. Think about it this way. Even a really experienced human driver can be fooled by an optical illusion, right? Or like a trick of the light.
Yeah, for sure. I've totally been tricked by those things before.
Exactly. Now imagine an attacker who can create those illusions specifically to target the AI's weaknesses. That's basically what we're dealing with here.
So they're like crafting a custom-designed optical illusion for the AI. That's crazy.
It is, and it works. These are called adversarial examples, and they're basically inputs that are carefully designed to trick the AI. And the thing is, these adversarial examples can be super subtle. Like sometimes it's just adding a few pixels to an image, and suddenly the AI is seeing something completely different.
So it's like you put on a pair of glasses and the whole world looks different.
Pretty much. And these attacks can target different vulnerabilities, depending on what the attacker is trying to achieve.
So they might want to make the car miss a stop sign or swerve into another lane or even just shut down completely. All sorts of bad stuff.
Exactly. It all depends on the attacker's goal.
Okay, so we've got these adversarial examples that can mess with the AI during inference. But you mentioned that attacks can also happen during training, right? Like that whole poisoning the well scenario.
Right. Remember we talked about training data being like school for the AI?
Huh.
Well, imagine an attacker sneaking into the school and messing with the textbooks.
So instead of learning to stop at a red light, it might learn that red means go. That's messed up.
It is. It's like teaching a kid that up is down and left is right. By the time they graduate, they're going to have a really messed up view of the world.
And that's basically what happens with a poisoned AI. It's learned all the wrong things.
Exactly. And its predictions are going to be totally unreliable.
So how do attackers actually do this? How do they poison the data without anyone noticing? It seems like that would be pretty hard to pull off.
It can be tricky, but the paper outlines a few different methods. One common one is called label manipulation. Remember we talked about labeled data, where we tell the AI exactly what each piece of data represents.
Yeah, like this is a cat, this is a dog.
Well, an attacker can just flip some of those labels, so the AI learns the wrong associations.
So they take a picture of a stop sign, label it as a green light, and slip it into the training data.
Exactly. And even a small number of these mislabeled examples can mess up the AI's accuracy. The paper actually mentioned a study where just flipping 40% of the labels in a dataset was enough to totally screw up the accuracy of a type of AI called a support vector machine.
Wow. So you don't have to poison the whole well, just a little bit can do a lot of damage.
Exactly. And it gets even more complicated because attackers don't always need direct access to the data to manipulate it. They can actually poison the well remotely by changing the data before it even reaches the AI.
Like intercepting a package before it gets delivered.
Exactly. The paper talked about a case where some researchers managed to trick a system that was designed to detect malware. They did it by, subtly changing the network traffic that the system was learning from.
So the AI was learning from bad data without even realizing it. That's sneaky.
It is. And because of that, it developed a totally flawed understanding of what a threat actually looks like, which made it much easier for attackers to slip through the cracks.
That's pretty terrifying. It's like the attackers are always one step ahead. But I'm guessing the researchers who wrote this paper didn't just focus on outlining the problems, right? They must have come up with some potential solutions too.
Oh, absolutely. It's a constant back and forth between the attackers and the defenders. But there are some promising approaches to make these systems more secure.
So like giving the AI a better immune system so it can fight off these attacks?
Yeah, that's a good way to think about it. One way is to develop AI models that are more robust, less sensitive to those tiny manipulations.
So they're less likely to be fooled by those adversarial examples and the data poisoning.
Exactly. There are a lot of techniques being explored right now, like using more advanced statistics during training or adding a little bit of randomness to the data.
So you're basically shaking things up a bit so the attackers can't find those little weak spots.
Right. And another really promising area is something called differential privacy.
We touched on that a little bit earlier, but can you remind me how it works?
Sure. It's basically adding some carefully calibrated noise to the AI system. It can be done during training or during inference. And it makes it much harder for attackers to extract sensitive information about the data that the AI was trained on.
Okay, so it's like adding a layer of privacy protection to the data.
Exactly. It's like putting on a disguise so no one can recognize you.
And if the AI is trained on, say, medical records, differential privacy would make it harder for someone to figure out a specific patient's health information just by looking at the AI's predictions.
Precisely. It's all about protecting individual privacy.
That's really cool, but I'm guessing there's a catch, right? Does adding all that noise affect the AI's accuracy?
That's the tricky part with differential privacy. It's all about finding that sweet spot between protecting privacy and maintaining accuracy. Too much noise, and the AI becomes useless. Too little, and the privacy protection isn't strong enough.
So it's a delicate balancing act.
It really is. And this is just one example of the challenges and opportunities in AI, security, and privacy. It's a rapidly evolving field, New threats are always popping up.
Sounds like it's a never-ending game of cat and mouse between the attackers and the defenders.
That's a great way to put it. But that's what makes it so exciting. There's always something new to learn and new problems to solve.
So what does all this mean for the average person, the people who are using AI every day, whether they realize it or not? What can we do to protect ourselves?
That's a great question. I think the most important thing is just to be aware of the potential risks. Just because something is powered by AI doesn't mean it's perfect.
So don't just blindly trust the algorithm.
Exactly. Ask questions, do your research, try to understand how these systems work and what their limitations are.
Okay, that's good advice. Anything else we should keep in mind?
I think it's also important to remember that this isn't just an individual responsibility. We need to be having these conversations as a society.
Oh, yeah, totally. Like policymakers, industry leaders, researchers, everyone needs to be involved in figuring out how to develop and use AI safely and ethically.
Exactly. It's a shared responsibility. We can't just leave it up to the tech companies to figure it all out.
Right. We need to be thinking about the bigger picture, like what kind of future do we want to create with AI?
Exactly. And that includes thinking about things like transparency and explainability.
Mhm.
We need to be able to understand how these systems are making decisions, not just trust them blindly.
So kind of like instead of treating AI as this mysterious black box, we need to be able to look inside and see what's going on.
Exactly, which is a challenge, right? Because AI systems are becoming so complex.
Yeah, it's like how do you create something that's both powerful and transparent? It's a tough balance.
It is.
Hmm.
But it's a balance we need to find if we want to build a future where we can actually trust AI.
Well said. It's definitely a lot to think about. We've covered a lot of ground today, from data poisoning to adversarial examples, differential privacy, the CIA triad.
It's a lot, but it's all connected.
It is. So, as we kind of wrap up this deep dive, what are some of the key takeaways for our listeners? What do you hope they'll remember?
Well, I hope they remember that AI security and privacy are really complex issues, and there aren't any easy answers. It's going to take a lot of ongoing research and careful thought and, people working together to come up with solutions.
So, it's a call to action, really. We all need to be involved in shaping the future of AI.
Exactly. And I think it starts with awareness,
Yeah.
being aware of the risks, asking questions, and demanding transparency for the people who are developing these systems.
It's been a fascinating conversation. Thank you so much for sharing your expertise with us today.
My pleasure. I'm always happy to talk about this stuff. It's so important.
It really is. And for our listeners, thank you for joining us on this deep dive. We know it was a lot to take in, but we hope you found it informative and maybe a little thought-provoking. Stay curious, keep learning, and keep asking questions. Until next time.